Okay, all right. So let's look at this question here. This is an extension to mechanics, projectile motion question. Um, it's actually my second attempt to record this lesson here because the first time I recorded about 40 minutes lesson and then I just realized after I finish, I tried to upload it online and I realized the microphone on our iPad is not turned on. I'm just going to show you here. So so there's no sound. What a waste of my time. Okay, so I'm going to record it again. Hopefully this time it works. Okay, so let's start again. I've been doing this question for a second time doing this question now. So two particles P1 and P2 are projected simultaneously from the point A and B, where AB is horizontal. The motion takes place in the vertical plane as through A and B. The initial velocity of P1 is V1 at angle V1, theta 1. So the particle goes this way, and the particle goes that way. This is theta 1, that's V1, that's theta 2, that's V2. All right, you may assume that's the equation of the motion. We can assume that. All right, so let's just highlight all of those. Now, for the first question, I'll ask you to show the condition for the particle to collide is when V1 theta 1 is equal to V2 theta 2. Well, if you think about the particle that goes from the left to right, okay, go from the left to right, and then there's another particle go from the right to left. When they collide, they're going to have the same vertical height. Okay, so that's the same the idea. They're going to have the same vertical height, which means if we want to find expression when they collide, the y is going to be the same. All right, so therefore what we can do is we can make a simultaneous equation in terms of y. All right, let's do it again. All right, for me, I'm just going to do this one again. For particle 1, y is equal to negative half gt squared plus v1 and t sine theta 1. For particle 2, y is equal to negative half gt squared plus v2t sine theta 2. All right, and we need to make sure these two are actually equal to each other. We want to find the time. Well, we're not finding the time. We're actually finding when they are equal to each other. We're proving this formula here. Okay, so if they are equal to each other, so we can just write this to equal to each other. Okay, all right, now you can cancel the negative half gt squared, both sides. You can also cancel the t here and there as well, just because they're going to collide at the same time. Okay, so because these two particles are actually fired simultaneously from the question says here, so therefore the time is going to be the same. All right, so in this case, v1 sine theta 1 is equal to v2 sine theta 2. Yep, so the first question, done. The second question, now suppose that AB is equal to 200. So the distance from this point to the point here is equal to 200. V1 is equal to 30. Theta 1 is equal to 4 sine inverse 4 over 5. Theta 2 is sine inverse 3 over 5. G is equal to that. And then the particle collides. Now we need to show that V2 is equal to 40. And then the particle collides after 4 seconds. Okay, so how would you do this question here? Well, let's just write down all the information we have. V1 is equal to 30 meters per second. Theta 1 is equal to sine inverse 4 over 5. Theta 2 is equal to sine inverse 3 over 5. G is equal to 10. Okay, when a particle collides, okay, we have the information that, when the particle collides, this is what we have proved. So in order for us to find a V2, then all we have to do is V1 sine theta 1 is equal to V2 sine theta 2. We can actually substitute everything we know. So V1 is equal to 30 times by sine theta 1. Sine theta 1 is just equal to sine, sine theta 1. If you move this one over, that's just equal to 4 over 5. So 4 over 5 is equal to V2, don't know. Sine theta 2 is 3 over 5. If we multiply both sides by 5, we should be able to get 120 is equal to 3 V2. V2 is equal to 40 meters per second. Okay, we proved. Sorry, I'm just doing it a bit faster than as usual because I've done the question. I've recorded the lesson and then there is no sound. Okay, so therefore, gosh. So that's why I've already know how to do the question. Okay. Anyway, next we need to show the particle collides in 4 seconds. Now, for a particle to collide in 4 seconds, if you pay attention to the AB is total distance of AB is 200. So all we have to do is we find the distance here for A to C, for example, and then we calculate the distance from C to B, and then we just add them together, and hopefully they are actually equals to 200, and then we can find out at the time when that's equal to 200. All right, so therefore the second part, we know that A to C, okay, so AC plus CB is equal to 200, and AC is equal to X1, and X2 is equal to CB. Now from the previous equation of the motion here, X is equal to VT cosine theta, so therefore X1 is V1T cosine theta 1. And that's V2T cosine theta 2 is equal to 200. Okay? Alright, so from here, how do I find it? Cosine theta 1 and cosine theta 2? Well, you have sine theta 1 and sine theta 2, and you can just draw triangles, right? Right angle triangles. That's theta 1, that's 4, that's 5, according to the conditions here. So now we know that cosine theta 1 is 3 over 5. And then from here, we also know that cosine theta 2 is 4 over 5. Okay, so therefore, once we know this information, let me just do it in the next page. Alright, so once we know this information, we can actually substitute the values inside, and that way we should be able to calculate what is the value of t. So V1 is equal to 30 times by the time, don't know the time, cosine theta 1 is 3 over 5, plus V2 is equal to 40 times by the time times by 4 over 5. That's equal to 200. Okay, if we times everything by 5, that gives us 90t plus 160 t, that is equal to 1,000. So that gives us 250t is equal to 1,000, and t is equal to 4 seconds. Okay, so we proved 4 seconds later, they're going to collide. Alright, now we need to find the height of the points of collision above A and B. Alright, find the height. So in order for you to find the height, we can just use the equation of the motion, either one for the y value here. We can either use the first particle, y coordinate motion, or we can use the second particle one. Okay, so that's alright. So for finding the y, we know the y is equal to negative half gt squared plus v1t cosine sine theta, v1t sine theta 1. So if we substitute everything, we know that g is equal to 10, t is equal to 4 seconds, we know v1 is equal to 30, t is equal to 4, and then sine theta 1, let me just check, sine theta 1 is 4 over 5, then we should be able to calculate everything out, okay? So let me just do this, that's 6, alright, and then I'm just using my calculator to avoid any further mistakes. So that is 96. Alright, so the final answer will be 16. Alright, so that's 16 meters above the ground. Alright. I hope you're actually, following. Last one is the question where, that's the last question is a bit tricky. We need to find corrected to nearest degrees the obtuse angle between the direction of motion of the particle at that instant when they collide. At that instant when they collide. Alright, so what we are doing here, let me just draw a diagram for you. We've got two particles, right? If you think about these two particles, the one that goes this way, and the other one that goes maybe that way here, they all have different angles, they all have different initial velocity as well, and we don't really know when they are collide. But if you look at this point, okay, just this point, when they collide, we need to find out what is the angle in between, okay? So in order for us to find the angle in between, basically it's like we're finding the tangent at this point and the tangent at that point, okay? And somehow, if we can find the tangent, we should be able to find out the angle. Alright, the total angle theta. Alright, so therefore what we need to do in order for us to find the tangent is we need to find the velocity, okay? The velocity at this point, alright, for both particles, at that instant. Okay, right. So therefore, for particle one, all right, we write down everything we know. X dot is equal to v1 cosine theta 1. Y dot is equal to negative gt plus v1 sine theta 1. Okay, and now let's find out all the things we know. Okay, so x dot is equal to v1 is equal to 30 cosine theta 1. That's 3 over 5. So it's 3 over 5, and that's what is that equals to? 16? No, 18. All right, so because this is equal to 80 meters per second, that's the horizontal motion. Now, y dot is equal to minus 10 times by 4, because remember, the time where the particle actually collided at each other here is when t equals to 4. All right? Okay, so plus v1 is equal to 30 times by sine theta 1, which is 4 over 5. That's negative 40 plus 24, and that's equal to negative 16. So what does that mean? So according to this, if you think about this as a vector, horizontal motion is going from the left to right, which is positive in this case, and that's 18 meters per second. Vertical motion is actually going this way. So it's negative 16. That's why it's going downwards. All right, so therefore the resulting motion is actually going that way there, diagonally. All right. So therefore, the motion is actually going down, okay? When the particle collides at least for the first particle, the particle is actually in the downward motion when they collide. So now what we need to do is find out the velocity at point, time equals to, at t equals to 4. All right, so all we have to do is use Pythagoras. All right, so that should be quite easy. Velocity is equal to the square root of 18 squared plus negative 16 squared. That is, let's do that. Right, so that becomes 24.083. So that's the overall velocity. But then, do we really need to find a velocity? I'm just thinking about this, all right? If we just want to find the angle, we probably don't even need to find the velocity. We just need to find the angle, because at the end, we're finding the angle in between, right? So if you think about that, we are creating, for example, I can just draw a line going this way, okay? And if you think about this, this is the diagonal we're looking at right now, okay? So that's not too good. How can I demonstrate that for you? Yep, that's what I'm looking at right now. Okay, so basically the two angles that, from this area, the two angles that's created by the two equation motion is, I'm just trying to draw something like that. Okay. I hope that you understand. All right. Okay, cool. So this is the angle here. We're finding this angle here first. Once we finish finding this angle, then what we can do is we can find the angle on this side for the second particle motion, and then we can combine the two angles together. So what I'm looking at is this angle. So in this case, I don't even need to find out the resultant velocity. I just need to find the angle. All right, and let's just call this as alpha here, for example. Alpha is equal to tangent inverse, okay? And then that's, pretty obvious, which is opposite of adjacent. That is 18 over 16. Okay. All right, so that's the first one. Then we can do the same thing for particle 2. We can do exactly the same thing for the second particle. X dot is V1, V2 cosine theta 2. But please remember this time, for particle 2, the particle is going from the right-hand side to the left-hand side. So we consider this one to be a negative, if you think about it this way, all right? The direction from the left to right is considered to be positive. So therefore, the direction from right to left is considered to be negative. So that's negative 40 times by cosine theta 2. Now, cosine theta 2 is 4 over 5. 4 over 5. So that becomes negative 32. Okay. We can do the same thing for the y dot. All right, for the y dot is the same. There is no positive or negative. Well, the direction is fine for the y 1. Okay, the reason for that is this is still going up, it's still increasing. So if it's still going up, it's still considered to be positive. That's negative 10 times by 4 plus V2 is 40. Sine theta 2 is 3 over 5. So that becomes negative 40 plus 24, negative 16. All right. Okay, so that means it's just the same thing, all right? So in that case here, what we can do now is we can draw the diagram that we should be able to figure out the answer quite easily again. So the particle is going this way, horizontally is 32 meter per second, all right? And then the particle is going down like that, going down, which is, let me just think, okay, going down like this, and that's 16 meter per second. All right, so the resultant one is going this way, and remember we're finding this angle here this time, which is beta. Are we finding this angle, or are we finding something else? Nope, we're not finding this angle. We're finding the other one on this side. Okay, we're finding this angle. That is beta. Okay, because if you look at this diagram over here, we're finding this angle here, which is that one there. All right, so therefore, if we use the same tangent, all right, then in that case, beta is equal to tangent inverse 32 over 16, which is tangent inverse 2. Okay, all right, so therefore, the overall angle in between, so the obtuse angle in between, all right, is equal to tangent inverse 18 over 16 plus tangent inverse 2. Okay, let's do the final calculation and see what the answer equals to at the end. Right, so the answer is equal to 111.8 degrees, and if you want to round to the nearest degrees, that becomes 112 degrees. And that is the angle in between of the two particles when they collide at that instant. All right, sorry, this lesson is, I actually ran through this lesson a bit quicker than as usual, just because I record the lessons and then there was no sound at all. That was so annoying, and I just have to record it again, okay? Let me know if you don't understand any of the process behind. That is considered to be a slightly harder question for the extension 1 student, I guess. But please remember that question, even this question is in an extension 2 textbook. In the older syllabus, that question was from the extension 1 textbook, all right, for the extension 1 students. So this is still considered to be an extension 1 level from the previous sort of course. Okay, thank you.